Shooting hoops. Putting something through a goal. Even though the game of basketball has only been around about 130 years, the concept of putting something through a goal is ancient. The Mayan game of pits is said to have been around since a decade before Christ in South America. It's basically a cross between soccer and basketball, where you try to bounce a ball through a vertical hole on a wall without using your hands. Then, in Springfield, Massachusetts, a doctor created a game where you shoot a ball through a peach basket. His goal? To create a non-dangerous game that would keep athletic men busy during the winter. The game was originally played 9v9, and the basket didn't even have a hole in the bottom. But those were simple times. Now basketball has become an incredibly detailed and scientific sport that's analyzed down to its most minute details, even at the highest level. NBA statisticians have stats up the wazoo. Advanced AI programs record information that most people would never even think to use in their life. The average mile per hour a player moves on defense, the amount of times each player touches the ball, or even things like categorizing a player's stats under whether or not they wear a headband. Recently, I've been using this application called Home Court, created by Jeremy Lin and Steve Nash, and it tracks all kinds of information about a player when they shoot. Leg angle, miles per hour before they shoot, the release angle, even things like how high they jump. I've always been a believer that there's a certain way you ought to shoot a basketball. Obviously, there's variations for each shooter according to body type, but there are some non-negotiables. 1. A straight shooting arm with an elbow tucked in. 2. Your primary hand under the ball. 3. Reduced interference from your offhand. 4. A tight snapped follow-through. 5. High enough arc to actually go in the basket. And 6. Consistency. There are some people who say form doesn't matter and just shoot the ball. Now, obviously, there are cases of shooters with unorthodox shooting form, but I would argue that it takes much more time and effort to be able to consistently shoot this way.
Now let's say I wanted to show this. What if I isolated one statistic from shooting to determine whether or not it has an impact on how well a player shoots? Using the Home Court app, I recorded the release angle and percentage of a player's makes and misses in an attempt to determine if there's a relationship between shooting angle and percentage. I'd been using this application before the Contemporary Math project, but I'm limited by the sample size because of the COVID-19 outbreak. I have some pre-recorded stats for a lot of people, but I only had most of them take about 30 shots. Ideally, this would have been like 50, so each shot is worth 2%. For the people who took more than 30 shots, I just ended up using their first 30, so it's equal to the people who only took 30. Something worth noting is that my sample isn't very random. I used everyone available to me because of this virus, and what I'd already recorded from people, friends, and basketball players from my small high school. So one could say that my curiosity in the project outweighs the necessity to have a truly random sample in this situation. Now there's a lot of variables here. It's impossible to isolate just one of them at a time. Somebody could achieve the right release angle and still have something that's fundamentally wrong with their shot. Just looking at the angle wouldn't necessarily tell you that. Another thing to note should be the conditions of the shooter. What if somebody's shooting on double rims? For those of you who don't know, even the best shooters throw up bricks on those Oregon City Park double rims. What about the temperature? Players' control over their arms and fingers can be reduced when they're cold. One noted problem when going over my data were these few strange outliers. 3 of the test subjects who are known for being great free throw shooters all shot below 50% in the same session. For example, this is Evan. Evan was Casco League Player of the Year. He shot 87.45% on free throws in games for the season. That's remarkable. For me, Evan shot terrible. Why is that? I think it's due to the fact that the gym was significantly colder than when I recorded other shooters, and I didn't allow anybody warm-up time. I'm testing the significance using the correlation coefficient and regression line equation, and one downside here is that it only takes into consideration each dataset's mean average, not the numbers for each shot. This becomes a dilemma when you test those who are just flat out bad at basketball. They're extremely inconsistent. One time they could shoot 8 degrees below the perfect angle, and the very next time shoot 8 degrees above it. But because of the nature of taking a mean of something, then we have a person whose average on paper would seem like they're shooting at the right angle. But this presents a problem for my hypothesis when they're shooting at my perfect angle and have terrible results. Because the test I'm doing is only applicable information for basketball players, for the sake of analysis, I'll throw out the data that came from non-hoopers. You can analyze a correlation by looking at data points on a graph. Let's say I want to put the angle of the shot on the x-axis and the percent on the y-axis. A test of the line of best fit would determine some kind of linear relationship between the data points. When dealing with correlation, a perfect positive relationship is equivalent to 1, and a perfect inverse relationship is equivalent to -1. So if there really was some kind of relationship between shooting angle and makes, in a perfect world, it would look like this. But we're not in a perfect world. It's unrealistic to believe that the higher you shoot, the more likely it is to go in. Much to the delight of my ancient high school Algebra 2 teacher, we would actually come across more of a parabolic relationship. This is because hypothetically we'd see the shooting angle and percentage climb together in a positive relationship, but once we reached my hypothesized angle of 55 degrees, they'd start going opposite directions, where the angle would keep on going up, but the percentage would now go down. This was actually something I noted with a lot of the female basketball players. The ones who shot lower percentages tended to shoot the ball drastically higher angles. An interesting thing to note would be that not a single guy I tested averaged over a 55-degree release angle, but the majority of the girls did. Now, I don't quite know what to make of this, but I like to think it's because most guys rely on strength to shoot the ball, while girls harness more of a launch. I entered the data values into Google Sheets in order to calculate my correlation coefficient. After all that, I came up with the number 0.6970 and so on. Now remember, the significance is based on how close it is to either +1 or -1, but that's a bit subjective. In order to make that judgment call, I need a critical value to help me, hence the eye test. I got this eye test table from some old high school materials. It helps you get an idea for the benchmark of a significant relationship for your sample size. But I'll test two different sets of data, the ones excluding inexperienced shooters and the ones that include everybody. So those both fall in the range of about 20 to 30. When I put the data values of the experienced shooters into Desmos, it graphs a line of best fit so I can really see the relationship these numbers are telling me. The critical value the eye table gave me was anything above 0.42, and the correlation coefficient is basically 0.7, which means there really is some notable relationship between degrees and percentage, because the correlation coefficient value was above the critical value. Now I'm curious what would happen if I put the outliers I excluded into the data set to see how much it affected the line of best fit. And it was really cool to see that the value still barely passed the test. But that didn't include one of the outliers. One monster outlier. When I entered this data value, it ruined everything. It was somebody whose shooting was so bad, so inconsistent, that they averaged the perfect angle, with a percentage so low that they couldn't even be seen on the graph as I currently had the scale. Ladies and gentlemen, my friend Jonas Corinthian Nutrock.